Welcome to the second video of building Cadric, the humanoid robot, and in this video we're going to be covering the assembly of the leg and the determining of the rest position. Now we're going to assemble the leg. To assemble the leg we require 5 servos, 2 for the hip, 1 for the knee, 1 for the ankle and 1 for the foot. So as I've done for the arm servos, I've color coded and marked each of the wires coming from the servos, and it is extremely essential that you don't skip this step. So now coming to this is a 12 into 18 centimeter aluminium plate that I've used as a foot plate, and I've used these L brackets to fix a servo onto this foot plate. And this is a 12 into 18 centimeter and this is a 4 into 12 centimeter piece of steel which I've used for extra stability. These are 3 different configurations of aluminium C brackets that I've used for the assembly of the leg. I've drilled a hole here to pass the wires coming from the leg servos to the chest box, and I fitted a bracket like this to fix the first leg servo. Now if I write the value 0 to the servo, I want the leg to be like this, perpendicular to the body in the spread out position. And if I write the value 65, which would be 90 according to the scale, I want the leg to be like this, parallel to the body. And if I increase the degree, I want it to go like this, inward. So now I'm going to mark the 0 position. So the leg would go like this and then it would come back if I fix a servo like this, but we want the leg to go like this, right? So we just have to fix it the other way around. After the value 0 has been written to the servo, we have to fix the bracket like this. This is the second case scenario that we've talked about when we were assembling the arm, the shoulder servo specifically, this one, in which the bracket remains stationary and it is a servo body that is moving. Now I'm going to fix a servo such that if I write the value 0, I want it to be at this position, and when I increase the values, it should go like this and then it should go back. So that in the future, if I want to program the robot to do, let's say, a high kick, it will be able to go like this to this degree, which is awesome. So, kapow. Now I'm going to mark this. So if I fix it like this, the leg would get extended backward and then it would come back to position 0. So, according to the second case scenario, I have to fix it the other way around like this. Now I'm going to fix this bracket like this. This is the knee servo, so this is position 0. It's going to bend back and then it's going to come back. So we can just fix it like this directly. So let's do it. After it has come to position 0 of the circuit, and we have to fix the next set of brackets like this. When the servo is at position 0, I want the foot to be like this, and when I increment the degrees, I want it to go backward, straight, and then forward like this. Now let's fix the servo. At position 0, we have to fix the bracket like this. position 0, I want the foot to be like this, parallel to the body. And then I want it to go like this and then back. So you have to fix the servo according to case scenario 2 like this. Now I'm going to fix this custom made L bracket. Now I'm going to attach the foot plate. Now let's fix the base. So now what we have to do is to take all the wires coming from the servo like this, tag them all together and then send them through the hole here to the chest box. Also take care that none of the wires get stretched and make sure that during the maximum working angle of the servos, for example of the foot servo, the maximum working angle would be this much. So the wire, it should be a little loose. It shouldn't be stretched like this because the connection would go loose. So it should be a little loose, just like this. That'll be enough. And then you can take them together. So now we've assembled the left leg, and just like this, you can assemble the right leg. Now let's determine the rest position of the servos. So the rest position of a robot is the position that it will be in when it is not doing anything. For example, when I've pressed none of the buttons, it doesn't do anything, right? It's going to stay still. So the position that it will be in then is what I call the rest position of the robot. So now let's see how we determine the rest position of a servo. Let's take the example of servos 4, 5 and 6. For servo 4, this is a 0 position, this is position 118, and this is position 180. So for the rest position, I'm going to choose this position, which is position 118. I'm going to note this down as the rest position of servo 4. Now coming to servo 5, this is position 0, position 65, and as we increase the degrees, it's going to go like this. So when the robot is resting, I want servo 5 to be like this. So this is position 12, and let's note this down too. Now coming to servo 6. For servo 6, this is position 0, 65, and 80. So for the rest position, I've chosen this position, which is position 100. So when the arm is resting, it will be somewhat like this. Thanks for watching.